Hello everyone, myself Dr. Feroza Dimirajkar, and today we will see a 8051 program to transfer 10 bytes from internal RAM to external RAM. So the main purpose of the program is to transfer 10 bytes of data from the internal RAM location. That is, we have selected here the memory locations starting from 30H to 39H to the external RAM. Here for external RAM, we have selected the memory locations starting from 40H to 49H. So the logic of the program here is the first step is to initialize the source and the destination pointers, that is R0 and DPTR. And the second step is here we'll be using a loop to read the data from the internal RAM to the external RAM. That is, we are reading from internal RAM and we are writing it to external RAM. Then we'll halt the program when the transfer is complete. So here I have taken 10 data, that is 11H, 22H, 33H, 44, 55, 66, 77, 88, 99 and 0A. You can choose the data of your own choice. That is, you can take your data of your own choice. Now these all data these are stored from the memory location starting from 30H, 31H, 32H, 33H and so on up to 39H. And these are the internal memory locations we have chosen. That is, we have chosen the internal memory locations from 30H to 39H. So these are the values before the execution of the program. Now, before the execution, the external memory location, that is the address which is starting from 40H to 49H, here all the datas are 0. Okay, so 40H is having 0, 41H is having 0, 42H is having 0 and so on up to 49H is also having 0. This is before execution. Here these are for the internal RAM and these are for the external RAM. That is, these locations we have chosen for internal RAM and these locations we have chosen for external RAM. Now, here I have said you that I have selected this data. These are stored at the memory locations starting from 30H to 39H. Now, what happens after execution? So, after execution, 11H will be transferred. That is, all the data which is stored from 30H to 39H, these all will be transferred to the memory locations 40H. So 11H it is transferred from 30H to 40H, 22 is transferred from 31 to 41H, then 32 is transferred from 33 is transferred from 32H to 42H memory location. Similarly, the other data are being transferred from the internal memory locations to the external memory locations, that is starting from 30H to 39H. So the data from these locations, it is transferred from 30H memory location to 39H memory location to 40H to 49H respectively. So these are the internal memory locations which we have chosen and these are the external memory locations which we have chosen. Now we will see the program. So here we will start with the initialization process. First instruction is org0000h. Then the second instruction is move R2 comma 0AH. Here we are loading the loop counter with 10 because we have chosen 10 data. You can change this 0A also. You can take it as 5, 4, 3. It depends on you. So next instruction is move R0 comma hash 30H. Here we are loading R0 with the internal RAM starting address 30H. Then next instruction is move DPTR comma hash 0040H. Here we are loading DPTR, that is the data pointer, with the external RAM starting address 40H. So what we are doing here? R2 is the loop counter initialized with 10, indicating that 10 bytes of data will be transferred. Then R0 points to the source address in internal RAM, that is 30H. DPTR is initialized with the starting destination address in external RAM, that is 40H. Now next we'll see the data transfer loop. So here we have taken the label up. The instruction here in the data transfer loop is move a comma at R0. So here it will move the value at the address in R0, that is the internal RAM, to the accumulator. The next instruction is move x at DPTR comma a. Here after move x you should have a space. Okay, after move x there should be a space here. So here it will move the value in the accumulator A to the external RAM address pointed by DPTR. After that we have increment R0, which will increment R0 to point to the next byte in the internal RAM. That is, earlier it was 30H, now it will become 31H. Next is increment DPTR. That will increment the DPTR to point to the next byte in the external RAM. Earlier it was 004H, 40H. Now it will be 0041H. So the next instruction is DJNZ R2 comma F. Therefore it will decrement R2. Earlier R2 was what? It was 0A. Now it will decrement it. It will become 09. And it will jump to this level up if it is not 0. Now R2 is not 0. Therefore it will jump to this level. Again it will execute this loop. So next time R2 will become 8. Okay. So again R2 is not 0. Therefore again it will jump to this. So here it will execute this loop. That is, this loop will be executed 10 times because R2 is initialized with 0A. 0A is nothing but 10. Okay. So what we are doing in this loop? Here the value at the internal RAM address is pointed by R0. Okay. It is moved to the accumulator. Then the value in the accumulator, it is moved to the external RAM address pointed by DPTR using move X instruction. Fine. Then R0 is incremented to point to the next byte in the internal RAM. After that, DPTR is incremented to point to the next address in the external RAM, and R2, that is the loop counter, it is decremented. If it is 0, if it is not 0, the program jumps back to the loop. Okay. Then after that what we have to do? We have to stop the program. So this instruction creates an infinite loop, halting the program after the data transfer is complete. Okay, this is the program. Now this is the result before execution. I have changed some data here. At 30H I have stored 01, 02, 03 up to 10. Okay. Actually you have to write this as 0A. Then here 40H location, this is the internal memory location, this is the external memory location. Okay, sorry, this is the internal RAM and this is the external RAM location. So initially here we are giving the data. So at 40H there is no data present, all are 00. After execution you should get the data which is in 30H to be transferred, okay, to 40H. So the same data will be copied here. Then when you are entering the internal the data at the internal RAM in the execution of Keel software, there at the memory window, memory 1 window, you have to write it as I:30H. I is used for internal location, and this is internal location. It is not internal data, it is internal location. Then for external we have to use X. Okay, for internal I, for external X. So these are the execution steps. What we have done here, in the first step we have initialized R2 is equal to 10, R0 is equal to 30, and here DPTR we have taken it as 40H. Then second step is the execution of the loop, that is the starting the loop. Here we have read the values from the address 30H are not in the internal RAM and stored it in the accumulator. Then write this value to the address 40H, that is the address of the DPTR, in an external RAM. Then we have to increment R0 to point to the next byte in the internal RAM, that is R0 will become 31H. Then increment DPTR to point to the next byte in the external RAM. So this DPTR, this value will become 41H. Then decrement the loop counter. So the loop counter was 10, now it will become 9. Okay, similarly you have to execute this 10 times until and unless what? R2 becomes 0. That is, this R2 loop counter becomes 0. So there will be how many iterations in this? There will be total 10 iterations. After that you have to enter the infinite loop and you have to halt the program. So this infinite loop is at the label H. Now we will see the execution of the program. So I will start the Keel software by double clicking on the icon of the Keel software. Now we'll start with the project. New Mu Vision project. I will use the previously used project. You can create a new project also. Yes. Select the device microchip. From this you have to select 8089 C51. Okay. Then click on no. Now go to the file, open new file and paste your program or type your program. I'll paste my program here. Control C and I will paste it here. Okay. Now I will save it. I'll save it by the name. It is internal to external transfer of 10 data bytes. Therefore, I'll write it as int to ext. I'll name. Remember that you have to save the program by .asm extension, then save. Okay. So earlier I have used this program name. Therefore, it is asking whether I want to replace it. I click on yes. Now the color has changed. Okay, when you store the program with .asm, then only the color of this font will change, otherwise it will not change. Now go to the target, then click on the plus symbol. You will get source group 1. Right click on this source group 1. Add existing files to group source group 1. Now search your program. Here it is int2 external.asm. Okay, add and close. Now you have to go to project. You have to click on build target. So there are 0 errors and 0 warnings. Go to debug, start or stop debug. Click on OK. Now memory 1. You have to use two memory windows, one for 30H and another for 40H. So memory 1, it is internal RAM. Therefore I'll type here I:30H. Okay. And I'll enter the data here 1122334455. I'll write it as 66 77 88 99 and here I'll write it as 0A. Okay, this is the data which I've given as the input at the internal memory location. Now I'll choose another memory window here, that is the memory 2, and here I want to transfer the data from internal to external. Therefore here I'll type as it as x colon 40H. Okay. Now I will execute the program. See, at 30H you have entered the data. Now that data has to be transferred to 40H location here. We will run the program. So run it. So you can see here the data which was earlier, it was 000. Now it has been transferred. That is, here you are getting 11, 22, 33 and so on up to 0A. So this was given as input at 30H memory location. Now it is transferred to 40H memory location, and that is the external memory location. This is how you execute your program to transfer the 10 bytes of data from the internal memory location to the external memory location. Okay, I hope you understand the program. Thank you.